Hello, hello. Yes. Good morning, students, all of you. How are you, students? After a long time, 2 days we have didn't met. The last class we are in a mole concept we completed. Is it right? One say. Good morning, all of you. Do all of you came? The 2 days we didn't take any class. Do you revise those 2 days? Say last class we completed mole concept. Numericals we did, no? Right. Now start writing next gram molar volume. Write today's date, student. Write heading gram molar volume. Gram molar volume. Wrote this granular volume is abbreviated with GMV. What we represent with GMV. What is the full form of GMV? Important, see, gram molar volume. Now see what is gram molar volume? The volume occupied by 1 mole of gas at STP condition. So what is STP? Standard temperature and pressure. So make a note, volume occupied by the volume occupied by 1 mole of gas. 1 mole of gas at STP condition. Then what is STP? See, STP is called standard temperature and pressure. Standard temperature and pressure. And what is the standard temperature and pressure? Later we study states of matter where temperature is maintained 0 degrees Celsius. That is, if you convert in Kelvin, this comes to 273 Kelvin, and pressure is maintained 1 atmosphere. And this condition is called STP condition. That means what is the volume occupied by 1 mole of gas at STP? The volume occupied by 1 mole of gas at STP is known as GMV, gram molar volume. Understood, students? What is GMV means? See, how we get this gram molar volume? Later we study ideal gas equation. Do you know ideal gas? We study later in states of matter. Ideal gas equation, Boyle's law, Charles law, Avogadro law might be studied in 10th standard. So ideal gas is given by PV is equal to nRT. This is called ideal gas equation where P is pressure, V is volume, N is number of moles. R is called universal gas constant. What is this R called? Universal gas constant. Now see, when you are considering volume, no, volume for 1 mole we are taking. So obtain V from it. V is equal to what should I write? nRT by P, no? N I have to take 1 mole, no? So 1 mole, what is the R value? It's a constant number, 0.0821. Temperature, when I convert in Kelvin, how much we are getting? 273. Upon pressure is taken 1 atmosphere. This comes to 22.4 liters. On simplifying, this is the value we get. In what units? Liter we get. And this volume we are calling gram molar volume. That means 1 mole of any gas occupy how much volume? 22.4 liters. If you convert in milliliter, it comes 22,400 milliliter. So hence here make a note, 1 mole of any gas occupies Are you following, students? The 1 mole, what is the gas of 1 mole you take? It will occupy how much volume? 22.4 liters. This is in SI unit. If you convert in CGS unit, 1 liter, how many milliliter? 1000 milliliter, no? That comes 22,400 milliliter. So you have to see whether the examiner is asking in liter or milliliter. This is SI unit and this is of what? CGS unit. Copy this. Do all of you are studying at home at a hostel or no? Daily revise the concepts of what we discuss in the class. And don't keep pending work. The topic of what we complete here, revise, recap that. Water bottle. No, good. Anyone, those who joined today or today for this online class, we started bridge course. Myself, Praveen Kumar. I take care of your chemistry. So be regular. Those who came or those who joined newly, be regular for the class system. And those who are already joined, so to see that day wise you revise the concepts thoroughly and work on that the concepts today and previously what we completed. Recap all that and do start solving questions. Material, if they have given any PW material, solve those questions till now what we discussed. Might be you got bridge course material. If you have that, try to solve the questions from bridge course material. So understood, Amma, what is gram molar volume? Gram molar volume is nothing but the volume occupied by 1 mole of gas at what condition? STP. Then what is STP means? Standard temperature and pressure. That means temperature is maintained how much? 0 degree Celsius. If we convert in Kelvin, it comes 273. And pressure is maintained 1 atmosphere. This condition is called standard temperature and pressure. And substituting in this is what we are getting, 22.4 liters. So 1 mole of any gas occupy how much volume means 22.4 liter, or it comes 22,400 milliliter at what condition? STP. Clear? Now write one question. Copy them all of you. Write one question. Find the volume occupied by, a question you write. Find the volume occupied by eight grams of oxygen at STP. Now see, in exam point of view, they ask on the concept of GMV. Question understood what is asking. What will be the volume occupied by 8 grams of oxygen at STP condition is saying. Now think how you approach. Question understood, students. What will be the volume occupied by 8 grams of oxygen at STP? Now tell me what is the molar mass of oxygen? Last class we discussed mole concept. No, what is the molar mass for oxygen? 1 mole of oxygen weighs how many grams? 32 grams. Is it right? So if I take 1 mole of oxygen which is weighing how many grams, student? 32. No, how you got 32? 16 twos are 32 grams. This will occupy how much volume means what you say? 1 mole of any gas occupy 22.4. No, so here 32 grams will occupy how much volume? 22.4 liter at STP condition. Correct? So if 32 gram is occupying this much volume, in the question I asked for how many grams? 8 grams I am asking. So for 8 grams of oxygen, what will be the volume occupied? Simple understood unitary method. 32 grams is 1 mole. If 1 mole of this is occupying 22.4 liter, for 8 grams of oxygen, how much volume does it occupy? So cross multiply 8 of 22.4 upon 32. So any cancellation, 8 multiple, 8 ones are, 8 fours are. 4 multiple will cancel 22.4 by 4 fives are 20 and 2 will be remaining, 4 six are 24. So what should be the answer? 5.6 liters it will occupy at what condition? STP condition. Simple, no? So understood all of you. 1 mole of any gas, what is the molar mass for oxygen? 32. 32 grams will occupy 22.4 liters. So in the question is asking for 8 grams oxygen, how much volume it will occupy. Clear? Now write one more question. Find the number of moles present in 5.6 liters of methane gas at STP. See, question understood what he is asking. How many moles will be present in 5.6 liters of methane? What is the formula of methane? CH4 gas at STP condition. Now think how you get number of moles from given volume. So simple now, 1 mole methane will occupy how much volume, students? 1 mole of methane, any gas of 1 mole will occupy how much volume? 22.4 liters at STP, no? If 1 mole is occupying 22.4 liter, in the question I asked you for 5.6 liter, how many moles it will be? So whenever they give volume at STP and if they ask moles, what you do? The given volume divide with 22.4. So how you get this? What the volume he has given 5.6. This 5.6 is to be divided with 22.4. Understood, students? So given volume by 22.4 will give number of moles. So 5.6 will cancel 56. How many times it will cancel? 4 times. No? 56 ones are 56 fours are. That is 1 by 4 means how many moles it comes? 0.25 moles. This will be the moles present in 5.6 liters of methane gas at what condition? STP condition. Understood, students? So in mole concept problems, when they give volume, in order to bring moles from given volume, what you do? The given volume is to be divided with 22.4. Are you following, students? This is what a GMV. Now write next Loschmidt number. Right heading Loschmidt, spelling Loschmidt. Important in mains, JEE as well as in NEET, they are asking what is Loschmidt number. It's a constant number. So see what is Loschmidt number? The number of molecules present in 1 cc of gas. What is cc? 1 cubic centimeter of a gas at STP condition. So write the definition: the number of molecules present in 1 cc. What is 1 cc, students? 1 cubic centimeter. Cubic centimeter is nothing but milliliter. Number of molecules present in 1 cc of a gas at STP condition. What is STP? Means standard temperature and pressure. E is known as Loschmidt number. So in exam point of view, they ask you what is Loschmidt number. Loschmidt number is nothing but how many molecules will be present in 1 ml of a gas at STP condition. Now see how we get this Loschmidt number. See, I am taking 1 mole of, imagine some oxygen gas I am taking. 1 mole of any gas, instead of any gas I take oxygen. Now this 1 mole of oxygen will occupy how much volume? If I ask you what is your answer? Since it is cc, I have to take in terms of cc. Can I say 22,400 cc it will occupy? Do you agree, students? See, 1 mole of oxygen, in that what will be the volume? Means what should I say? 22,400 cc at what condition? STP, no? Now the same 1 mole which is occupying 22,400 cc will have how many molecules? If I ask you, what you say? The same 1 mole of gas which is occupying 22,400 will have how many molecules? Avogadro number, that is 6.023 into 10 power 23. These many molecules will be present or not? We studied mole concept, no? 1 mole of any gas of that occupying 22,400 cc will have these many molecules. Now in the statement what we wrote, how many molecules are present in 1 cc? If 22,400 cc is having these many molecules, for 1 molecule what will be its volume? The volume occupied by 1 molecule of the gas. So what you do, this 22,400 is to be divided with what? Avogadro number. What is the value of Avogadro? 6.02 into 10 power 23. Are you following, all of you? See, copy this. 22,400 is to be divided with Avogadro number. Now I write it in on the top. See, this 22,400, what is the volume divided by Avogadro number? What is the value of Avogadro? 6.02 into 10 power 23. Now 23 you bring numerator. This comes 10 power minus 23. And I removing these two zeros. That comes how much? 10 power minus 21. Correct? And this you take approximately 6. So because 6.02, 2 multiple 2 3s are 2 112s are. So divide 112 upon 3 in the rough work. So when you divide 112 upon 3, how many times will go? 3 3 is 9. This 3 multiple. 3, 2 3s are, 2 1s are, 2 2s are. So divide 112 upon 3. 2 3s, 2 1s, 2 2s. 22,400 by Avogadro number. So simplify this: 2 1s, 2 1s, 2 2s, 2 3s. 112 upon 3. Simplify it, how much you get? 22,400 by Avogadro number. So this 23, when I am bringing numerator, this becomes 10 power minus 23, 10 power minus 21 it comes. 2 3s are, 2 0 1s are, 1 1 2. So divide 1 1 2 with 3. That should come nearly, check, 0.279 into 10 power 21 minus 21, or when you remove the decimal 0.0295, it should come nearly 2.79 into 10 power minus 19. Check, nearly 2.79 into 10 power minus 19. That number we are calling Loschmidt number. So if you remember well and good, the value is how much? 2.79 into 10 power minus 19. This is the number called Loschmidt number. What is Loschmidt number? How many molecules are present in 1 cc of gas? Check, all of you. This should come 0.029279 into 10 power minus 27. And when you are moving decimal after 2 digits, so here what we did, here I have to take 1 ccm. What we have done mistake, see, if 22,400 cc is having Avogadro number of molecule, for 1 cc of the gas will occupy how much? That comes how much, say students, here do correction here, see, then what we have to do, simplify here, answer should come, check everyone, that comes Avogadro by 22,400, that is 6.023 into 10 power 23, that is to be divided with 22,400. These two zeros I am bringing numerator, that becomes 10 power minus 2, this makes 10 power 21 amount. So this comes 2 3s are, 2 112s are. Now previously we did 112 upon 3, so it's not 3 upon 112. Divide 112 upon 3, that comes how much, check, 0.0 2 times. So nearly 0.0279 we get, check them all of you, into 10 power 21. Or on putting the decimal after 2 digits, we get 2.79 into 10 power 19 plus 19. It is plus 19. See, 2 power 79 into 10 power 19. Check all of you whether you got the same answer or not. And this constant number we are calling Loschmidt number. That is the number of molecules present in 1 cc. Understood, all of you? Copy this. So its number, what is the constant number? 2.79 into 10 power 19. If you remember, well and good, or you can calculate at that time. So how you get the volume 22,400 is to be divided by, sorry, Avogadro is to be divided by 22,400. This is a constant number, and that number we are calling as what? A Loschmidt number. So in exam point of view, they ask you what is Loschmidt number. Loschmidt, understood all of you? Loschmidt number is nothing but how many molecules are present in 1 cc of gas at STP. And it's a constant number. So we got this values. Avogadro number is to be divided by 22,400. As you know, 1 mole of gas occupy 22,400 cc. In that 22,400 cc, how many molecules will be there? Avogadro number of molecules. So for 1 cc, what will be the molecules? Find out. Simplifying that, you get answer 2.79. Check all of you got same answer or not. 2.79 into 10 power 19, and this is a constant number. We are calling it as Loschmidt number. Put star mark for it. Understood, Amma? Clear for all. Now write next vapor density. Write heading vapor density. Copied all of you. Next write heading vapor density. Copied all of you. Understood, no? Till now what we discussed, what is Loschmidt number, what is gram molar volume. Right, next heading vapor density. Now what is vapor density, see student? Vapor density is given by density of the gas by density of hydrogen. So vapor density is nothing but density of the gas upon density of hydrogen. Copy this relation, important in exam point of view. They ask vapor density is nothing but density of the gas upon density of hydrogen. Now just now we wrote no ideal gas equation, student. What is that ideal gas equation? PV is equal to nRT we wrote, no? Now in place of n number of moles, what we write? Mass by volume, is it right? So see what I am writing, PV is equal to W by M, mass by volume, mass by molar mass. So this V I am placing here, mass by molar mass, this will give number of moles into R into T, correct? Understood, no? So number of moles what we are writing, mass by molar mass. Now what you do, bring this V to denominator. So bring this towards right side, then what we write, P is equal to WRT by M into V, correct? This V I brought to right side. Now in place of mass by volume, what I can write, students? Mass upon volume. Since density is equal to what? Since density is mass per unit volume, no? So now in place of this W by V, what I can write? Density. So finally what we write, P is equal to dRT by M. Getting idea all of you? So in place of mass by volume, I introduce D. What is D here? Density. R is universal gas constant. T is temperature. M is molar mass. Now at a given temperature, now bring this density. D, can I write it as Pm by RT, students? This, when I bring this D, density is equal to what I can write? Pm by RT. Here R is a constant, temperature is constant, pressure is constant at STP condition. Then how is density related with molar mass? Directly, no? So density of the gas is directly proportional to molar mass of the gas. Do you agree, all of you? Since density is directly proportional to molar mass, then in place of this, what can I write? So vapor density of the gas is equal to density of the gas by, that is molar mass of the gas by molar mass of whom should I write? Hydrogen. Molar mass of the gas by molar mass of whom? Hydrogen, no? So what is the molar mass of hydrogen, students? Molar mass of hydrogen comes how much? 2, no? Molar mass of hydrogen is 2. Then what is the relation? Molar mass of the gas is equal to vapor density into 2. Twice of vapor density will give what? Twice of vapor density will give molar mass. Understood, student? For a gas, vapor density into 2 will give molar mass. This is the important relation between vapor density, molar mass. Copy this. So in the problem, when they give vapor density and if they ask you to find molar mass, what you do? Vapor density you multiply with 2. So twice of vapor density will give what, student? Molar mass. Clear, students? Understood? So vapor density in exam, vapor density is nothing but density of the gas by density of hydrogen. And how is density related with molar mass? Density is directly proportional to molar mass. So in place of this, what I can write? A density place I can write molar mass. So vapor density of the gas is equal to molar mass of the gas by molar mass of hydrogen. And what is the molar mass of hydrogen? 2. So when we bring relation, what we write? A vapor density into 2 will give molar mass of the gas. Write one question. The vapor density of a gas is 22. Then find its molar mass. So question understood. Vapor density of the gas is given 22. What will be its molar mass is saying. So how we get, what is the relation for the vapor density molar mass? Molar mass of the gas is equal to twice of vapor density, no? So direct simple. So what you do, this 2 is to be multiplied with 22. So what should be the answer? 44 in what units? U. What is U? Unified mass. So with this mole concept has been completed, right? Next heading, concentration terms. Next one discussion we have to study concentration terms. Copied all of you this one, understood? No? Till now what we learned, gram molar volume, law speed number, what is vapor density. Now next concept, right heading, concentration terms. Concentration terms. Now what is concentration, students? Amount of solute present in given amount of solvent. You know solvent is what? Water. In the water, how much amount of solute is present is called concentration. So what we define for concentration, make a note, amount of solute present in given amount of solvent. Given amount of solvent is known as what? Concentration. No? So generally concentration in our syllabus we express in various ways. So how much amount of solute present in the given solvent we express in different ways. What are those in our syllabus? One, we are having mass percentage. Another, we are having volume percentage. Another, we are having mass by volume percentage. Another, we are having mole fraction. Another, we are having molality, small m. The last one, we are having molarity. Understood? There are various terms to express concentration. So write heading, expressing concentration terms. Important in JEE mains as well as in NEET, they ask you how we express concentration. Expressing concentration terms. To express the concentration terms, in our syllabus 1 we are having mass percentage. So mass percentage is shown in textbooks with what? Small w by capital W. This is called mass percentage. The second one we are having volume percentage. So volume percentage is shown by small v by capital V. This is used in beverages. And the third one we are having mass by volume percentage. Mass upon volume percentage. This is shown by the symbol W by V. And the fourth one we are having mole fraction. Mole fraction is shown by the symbol chi. with the symbol what? Chi. This is chi we say. And the fifth one we are having molality, small m. The fifth concentration is molality. Molality is shown with the symbol small m. And the last one we are having molarity. Molarity, see the difference between molality and molarity. This is shown with capital M. So these are the 6 terms by which we express concentration. Later we get into the topic, some basic concepts of chemistry. There also we revise the same thing. So mass percentage, volume percentage, mass by volume percentage, mole fraction, molality, molarity. Copy all these terms and now we discuss one by one. Are you following, students, all of you? So these are the various concentration terms important in exam. They give numericals on this. Copied all of you, mass percentage. Now we discuss one by one. Right heading mass percentage. Copied them all of you, mass percentage, volume percentage, mass by volume percentage, mole fraction, molality, molarity. Now we start with mass percent. Right heading mass percent. Mass percentage is shown with what? W by W. Now what is mass percentage? Observe here, understand, simple it is. Suppose two components are there, A component and B component in solution. Now among the two components I want mass percentage of A. So how I get mass percentage of A, students? See, mass percentage of A to get mass of A upon what? Mass of A plus mass of B into 100. No? Same way if I want mass percentage of B. So how do we get mass percentage of B? Mass percentage of B will be equal to, how I get mass of B by mass of A plus mass of B into 100. So hence what we define, understood, it is nothing but amount of solute present in 100 grams of solution. What is the definition for mass percentage? Amount of solute present in how many grams of solution? 100 grams of solution is known as mass percentage. Understood all of you? So mass percentage is nothing but mass of solute by total mass of solution into 100. Copy this. Understood? No, simple it is, mass percentage. Now tell me, student, will it be temperature dependent or temperature independent? They ask in exam. See, there is no volume term no here. Is there is any volume term here? No, no. So it is independent on temperature. So make a note, mass percentage is independent on temperature. Mass percentage is independent. It doesn't depend on temperature as there is no volume term. Independent on temperature. Clear, students, all of you? Are you following on everyone? Mass percentage is nothing but amount of solute present in 100 grams of solution. So mass percentage of A component to get, what should we do? Mass of that A component by total mass. Same way mass percentage of B to get, what we do? Mass of that B component by total mass into 100. And it doesn't depend on temperature. Write one question. Now see in exam how they ask, an unknown solute X. An unknown solute is there X, weighing, it is weighing 5 grams, present in 25 grams of solvent. Then find the mass percentage of solute. question understand what I am saying. One unknown substance is there, which we are calling solute X. That unknown solute is weighing how many grams? 5 grams, and that is present in 25 grams of the solvent. That is water. Generally, water will be the solvent. And what will be the mass percentage of this solute in this 25 grams of solvent we want? Think over how you approach. Simple, no? So, how do we get mass percentage of solute, students? So, in order to get mass percent of solute, the mass given 5. So, make a note, observe, you might be got answer, mass percent of solute is equal to mass of solute given 5 to me by 5 plus 25, no? Total mass of the solution into 100. That comes how much, student? 5 by 30 into 100. Any cancellation? 5 ones are, 5 six are, 2 threes are, 2 50s are. Divide 50 upon 3 in the rough work. So how much you get? 50 upon 3, 3 multiple 3 ones are 3, 3 six are 18, and subtracting this you get nearby check. Is it coming 16.6? So mass percentage of solute comes to be 16.6. Understood? Simple, no? So what amount of solute, this x gram is present in 5 gram of solvent, what will be the mass percentage? So how do we get mass of the solute by total mass of solution into 100? Simple, no? Clear? And is it temperature dependent or temperature independent? If they say it is temperature independent, because there is no volume term. Clear? Alright, second concentration, volume percentage. Clear for all? Right, second one, volume percentage. Now what is volume percentage? See, just like mass percentage, we learned, no, V by V we say. In textbook they show like this. So same thing, see, previously mass percentage, this is volume percentage. Suppose two components, assume A and B are there. Now in these two components I want volume percent of A, student. How I get? Same thing. So volume percent of A, how do I get volume of A upon total volume of the solution? No, student. Volume of A plus volume of B into 100. Same way, volume percent of B, to get what we do, similar way, volume of the B component by total volume of the solution into 100. Understood? So what we define for volume percent? Amount of solute present in 100 ml of solution. Is present in 100 ml of solution. Clear? That is called volume percent, and copy this relation. Clear? Understood? And will it be temperature dependent or temperature independent? Means yes, temperature it will depend. Why? There is volume term. So right here it is temperature dependent. Following on? So will it depend on temperature? Means surely it will depend, because there is volume term. Previously it is independent. Why? Because there is no volume term. And see one more point. In textbooks you will observe like this: 10% V by V ethyl alcohol. What is the formula of ethyl alcohol? You know, in 10th standard ethyl alcohol, organic chemistry, you know, C2H5OH. This is called ethyl alcohol. So in textbooks they will show, they will represent like this. What does 10% V by V mean? 10 ml ethyl alcohol I have taken. To that 10 ml, how many ml water I have added? 90 ml water we have added. To make it how many ml of solution? 100 ml of solution. So understood what I am saying? This 10% V by V means, what does it mean? 10 ml of ethyl alcohol is been added to how many ml of water? 90 ml of water. To make it how many ml of solution? 100 ml of solution. So understood the concept? 10% V by V is nothing but 10 ml of ethyl alcohol is been added to 90 ml of water. And generally volume percentage, where do we express? In beverages we express. like beers, champagnes, it is expressed in beverages. So generally this concentration term we express in beverages, copy this. Understood all of you? 10% V by V ethyl alcohol means 10 ml of ethyl alcohol is been added to 90 ml of water. To make it how many ml of solution? 100 ml of solution. Following all of you? Simple, no? Just like mass percentage, volume percentage. Write one question. Copied all of it. Write one question. 20 ml of ethyl alcohol is added to 30 ml of water. Then find the volume percentage of ethyl alcohol. Question understood? Simple. What he has taken 20 ml ethyl alcohol he has taken, to that 20 ml he has added 30 ml of water to it to make it 50 ml of solution. So in that, what is the volume percent of ethyl alcohol? Simple, no? How we get volume percent of ethyl alcohol? To get what we do, the volume what we took 20 ml by what is the total volume of the solution? 20 plus 30. What is the total volume? 20 from ethyl alcohol, water 30 into 100. That comes how much, student? 20 upon 50 into 100. So this will cancel, 0, 5 will cancel by 2 times. So answer will be 40% will be the ethyl alcohol. Clear, understood all of you? Simple, no? So volume percentage understood all of you. Mass is mass percentage we learned. What is volume percentage we learned. Now write next heading, mass by volume percentage. What is the third concentration? Mass by volume percentage. And this is shown by the text in the textbooks. You will observe that this W by V. Now what is W by V? Amount of solute present in 100 ml of solution. Right, definition, amount of solute present in 100 ml of solution. And where do we express this concentration? If you observe tablet backside, pharmaceuticals, on the tablet backside if you see, sometimes they will mention like this, 10% W by V NaCl. Now what this 10% W by V NaCl mean? 10 grams of sodium chloride is been present in how many ml of solution? 100 ml of solution. Understood what I am saying? The 10% W by V of NaCl means, what does it mean? 10 grams of sodium chloride is present in 100 ml of solution. This is what mass by volume percentage. So mass by volume percentage is given by relation mass of solute by mass of solute upon what, student? Volume of solution into 100. This is the relation for mass by volume. Now, will it be temperature dependent or temperature independent? Means sure it will have temperature dependence as there is volume term. So here make a note, it is temperature dependent. Are you following, all of you? See, mass percentage, where do we express this? In pharmaceuticals. You know, in medicines like that, it is expressed in pharmaceuticals. So mass percentage, mass by volume percentage is nothing but how much amount of solute is present in 100 ml of solution. So what does 10% W by V NaCl means? 10 grams of sodium chloride has been present in 100 ml of solution. Clear? With this mass percentage we did, volume percentage we did, mass by volume we did. Now write next mole fraction, the last one. Fourth one, write mole fraction. Now see, mole fraction is shown by the symbol of chi. What is that symbol? Chi we say. Simple. Now what is this mole fraction? See, suppose I am having two component, assume A component and B component. Then I want mole fraction of A component I want. Then how I get? See, mole fraction of A, to get what we do, number of moles of that particular component A by total moles of both the components. That means moles of A plus moles of B. Hence what is mole fraction? It is this simple. It is the ratio between number of moles of one component to the total moles of all the component. Same way mole fraction of B I want. How I get mole fraction of B? The number of moles of that particular component. What the mole fraction you want, that is to be taken on the numerator. Number of moles of B component by total moles of both the component. A component plus B component. Understood? So write definition simple. What we define? It is the ratio between number of moles of one component, number of moles of one component, number of moles of one component to the total moles of all the component. To the total moles of all the component. Understood, student? Simple. It is ratio. What we are taking, ratio between moles of one to total moles of all the component. And write this relation. And what is this Na? Number of moles. Moles, you know how to bring moles, mass by molar mass. Moles of A component by moles. This is moles of B. And will it be temperature dependent or temperature independent? As there is no volume term, it is temperature independent. Right? It is temperature independent. Now, does it have any unit? As it is ratio, it doesn't have any unit. And make a note, it has no unit. So in exam they give statement wise what will be the unit of mole fraction. As we are taking ratio, mole fraction doesn't have any unit. And see, one more important, in a binary solution, when you are taking the sum of the both components, that is chi A plus chi B, the sum of mole fraction of two components will be equal to 1. Mole fraction of A component plus mole fraction of B component should be equal to what? 1. So in a binary solution, binary means what? 2. The sum of mole fraction of A component plus B component should be equal to 1. This is important. Copy this relation. So tomorrow we will work out from mole questions from mole fraction, and tomorrow we discuss molality and molarity. Following students, all of you. So all this what you do today, once you recap and come tomorrow. Till now what we completed, mole concept we completed, concentration terms I started just now. So you revise all these concepts and practice on that. Okay. So all the best. I'm ending the session now, right?